Welcome. So, Kafka to the Maxka, also known as Kafka Performance Tuning. I'm the Hortonworks practice lead at a company called YopWorks. Got a dashing photo. Because everyone asked me about YopWorks, I'm going to explain it. And once I explain it, you will never, ever forget our name, which is fantastic. The branding here is amazing. OK, so Horton Hears a Who. Does anyone not know this story somewhat? OK, perfect. I'll remind you. OK. So just so you know, Horton is the big elephant. He can hear some magical people that are on this little piece of fluff that can talk to him, but no one else in the world can hear him speaking. So what do? They make this noise called yop, and then everyone hears them, and then they realize everything's fine. So what you should take from this is that Horton and everyone else in the world hears the YopWorks. Hortonworks, the YopWorks, OK? Good, got it. Now, to Kafka. Quickly, the agenda for today. I'm going to briefly touch on performance tuning. It was mentioned in the title. I would be inept if I didn't get to it. Then we're going to talk about Kafka, and I'll try and move quickly to it because I know you came here more for Kafka than necessarily to hear me talk about performance tuning. OK? So the question, guys, you've probably been asked this by your boss. You need to improve Kafka. What do you need? More servers, more brokers. Perfect. Yes, time and money. It's exactly what you said. OK? You need time, you need money, you need resources, okay? There is no magic bullet that you're going to find. Guesses are just guesses. Without empirical testing of your theories, they are just theories, they're not fact. And so that means that, as some of you already just said, we have to have identical hardware, identical data, identical use cases being actively activated on your Kafka cluster, okay? Without these, you're not actually testing, okay? What you are doing is you're creating a lot of garbage in, which will give you garbage out. You will tune to that fake data that you've gone and created. That's what will run really well in your system, okay? If, on the other hand, you used production-level data or even production scenarios that you've recorded and replay them, then you'll be tuning against that, which is, I think, what you want, okay? So when you're actually doing testing, test data doesn't work. Real production data does work. And that's what I'll give you testing. And my reminder to talk to you about what load testing is. Okay? Who does know what load testing is? Okay, great. So let me go over it. So if you're trying to do performance testing, you would like to load the server. So that's where the load testing comes from. We're trying to make it under a load that is sufficient that it starts to bulge. It starts to break down, the bottlenecks expose themselves, and you can understand what's happening, okay? So the test is not necessarily a happy test. You're trying to fail. You're trying to make your server fail. It's not what you always think about doing, but it's something that you need to do, okay? Even though I've got a lot of data that I'm going to put out today, and I've selected some properties that I think are very valuable to talk about and should apply to most places, everybody's different. Everyone has a unique signature of data, of hardware, of different topics that they're taking in, how they've done their segments. So again, we have to go in. We can go in with best practices. We can go in with generalities, but still, you have to test. And you should expect that there's going to be different conditions. If you're working for you, won't necessarily work for the next person. And when we are doing that load testing, we actually want to tune the bottlenecks. Yes, it feels really good when you find something and you're like, aha, this is, according to Matt, I must make this change. See, I can see it right here. It doesn't matter. Don't make that change necessarily if it's the case that that's not where the bottleneck is. Like if you find out Kafka is actually not the problem, it's the app server, you can tune Kafka all you want. It won't do anything with that server. Or if it's your writes to HDFS, tuning Kafka is not going to help you. You have to find something on that side. So take it in as a whole picture. Okay. So your boss understands, in a general sense, that this is what Kafka is. I know that you actually understand that this is what Kafka is. Okay? And if you don't understand that what this picture right now, The rest of this talk is going to be harder and harder, because I assume that we're at least talking about this level when you enter the room, okay? And if you want to slip out, I know that there's cocktails next hour. Don't worry about it. I'm not going to call you out. But I am saying that this is a general slide that I'm not even going to explain. So I'm going to ask for forgiveness, and I'll explain it afterwards gladly to you over a cocktail. Okay, so we're going to go start from the basics, and we're going to run as fast as we can to get as far. I know I'm the last session of the day, and I have a lot of slides, so I'm going to try and pick up the pace a little bit, especially when we're talking about the OS basics, because no one likes talking about OS basics. But you have to if we're going to be complete. So to start with, I am not a Windows hater. I've got a Mac on. I have used Windows regularly in the office. I've got a Linux VM running on this at all times. Windows is not as well supported, and it's only not as well supported because not as many people install on it. For whatever that reason that is, I will just say it is not as well supported as Linux is. You can still run it on there. It runs just fine. It's written in Scala. It compiles to Java, runs anywhere. But there are some special settings that you should look into that I'm not going to cover today, okay? But I'm making you aware that they are there, and search for Windows in the documentation on the Apache website will mostly alert you to probably about 90% of them. So this is a basic for all performance across Hadoop, all systems. Okay, if you're doing reads, you want no A time. I don't even know if that's how you say it, but no A time is when I'm going to say it. This tracks the last file access that someone reads. If you're doing this on every single read, it's bad. This is bad on, like I said, all systems that do high performance reading. ext4, widely in use, and generally very good. XFS is faster, okay? And there's even some reference material to show you that that is. Here are the magic JVM settings. These are just stock. They're taken right out of the Kafka website, so please go there and review them, okay? They've done work to make sure that you're actually going to get good performance out of these. Again, I would still take that with a grain of salt that these configurations, although could be magic if you haven't added them to your existing Kafka, do this. I've gotten you performance improvement. But we all know I'm only pushing the needle a little bit when we're tuning JVM. JVM is not the be-all, end-all, will save you, okay? You can push the dial a little bit, but that's about it. But I do recommend if you did stock install, or your buddy Bill did, and you know he doesn't really follow the directions that well, you should go back and check this out. You might get some performance improvements. It's amazing how often just me putting that slide up gets photos and people understand. Okay. The file descriptor limits, if you know Linux, that's going to come up because there's a lot of open files on your brokers, okay? Maybe not everyone knows the math, but the math is actually there's overhead on top of partitions times segments, okay? That's going to come up, and you're going to have a failure. So I don't really consider this necessarily performance tuning, just making you aware of something that's critical. And later on, I'll show you why I bring it up. It's because I want you to all upgrade to 10 to be fast. You'll be faster when you get to 10. And when you get to 10, there's a 30% hit on the open file descriptors. Okay? So I've given you the warning, and I've told you what to do. Upgrade to the maximum you can. Okay? There's always more fixes, and you can always read. You can read online about everything that's improved over time. And if you are looking for the best performance, the easiest suggestion for me to you, without significant purchase of anything, is just upgrade. It's open source, guys. It's free. Okay. VM set the swappiness to 0. We just had to finish that setting off, so let's get it done. If you weren't aware, big data systems, when they like to write data, they like to write data fast. And to write data fast, you don't want contention, which means that you should only have Kafka writing to its own physical disk. If you need more speed, you could just buy new disks instead of new servers, as long as you have more space in your drives. These should be set up in a JBOD configuration, just a bunch of disks, not RAID, okay? You don't want RAID anything. Even if they tell you to use RAID anything, don't use RAID anything. There's still overhead on top, and it's not as fast as if you had just 10 disks just being disks, writing and reading, okay? On top of that, RAID doesn't make any sense because we already have a default replica of 3. So if you raided the replica, you're double dipping and spending more time and energy on stuff you don't need to do. I hope that's clear. The folders are written in a round-robin configuration. Some of the stuff that you get coming with 10 and a not exhaustive list of these is you actually do get an extra 8 bytes per message. This could be problematic for some people. It's 8 bytes, you're going to be fine. No longer does the broker do decompression. When you send from the producer the message, it compresses it. It was decompressing it, then writing it to it. It's not doing that anymore. That's also why we had the file descriptor limit go up, because now it's indexing the messages in a compressed format and has to keep track of the timestamp as well. In Kafka, just like in your car, you have a seatbelt, right? And you should wear your seatbelt at all times. Okay? There's times when you shouldn't wear your seatbelt. I haven't figured that out yet. I was trying to work on something for that. But when we're talking about Kafka in general, we want to use the defaults, which are the seatbelts. Okay? The rest of this talk is going to go beyond that. So we're going to take the safety rails off a little bit. You should only do this if you've actually thought through what you want to do and hopefully done some testing to make sure these settings work for you. Okay? So I definitely encourage moving away from the defaults, but if you want to be safe, you're not going to get in trouble with the defaults. Okay? So let's start with the settings for the producer. Okay? The producer is where all the messages are generated. There's something called ACKs. And ACKs are acknowledgements of the message. Okay? So the producer can send messages and, like UDP, set it and forget it. Okay? It's fantastically performant. Why? Because you don't have to wait for any responses. You just keep writing. You get one, write another one. Boom, done. Somewhat problematic because you don't know that it ever got the message. So there's a little bit more of higher risk in terms of data loss because you're not actually checking that any of the message made it. Okay? If you set acknowledgement to 1 as a parameter, it will wait till 1, acknowledgement comes back, and that's going to be from the leader. Okay? So that's a good mix of performance, and at least you're mitigating your risk a little bit in terms of data loss. You knew that the rate completed on the leader. Okay? Or you can be paranoid, and you can turn on all, and that means that for all replicas must reply, and they will reply to the leader, and then the leader will reply back to you to let you know that your write was completed to all of them. Okay? I don't know anyone that needs this, but I'm sure that you'll come up with an edge case to educate me. So please, if you do, someone's nodding in the back, great. Yeah, question?
Is it only 0, 1, or all, or can you specify an integer, like 2, if you've got 5 and then plus?
No, it's just 0, 1, and all. That's a good question, though. Now I'm going to go look in the documentation. But actually, I know the documentation says 0, 1, and all. It used to say 2 instead, and the 2 used to mean that it was waiting for all of them. So they changed it. So what is the default? I think the default is 1. Actually, yes, I believe so. I always set it to 1 anyway, so I don't even remember anymore. Sorry, that's what the default is set to. Okay, so now let's talk about, when we're talking about performance, what are we trying to do? Okay, individually, a message's latency is the length of time it takes to process. Okay, individually. If we put them all together, it's the number of messages that were processed. Okay? That's called throughput. So latency and throughput, they're opposite ends of the spectrum. And I'll help you to understand why. So here we have our batch. The batch has 3 messages in it at time 1, 2, and 3, so linearly in order. Okay? The worst latency is going to be message 1. Why? It entered the queue first. Now it waits for all the rest of the messages to be batched together and be sent off. So latency is going to be bad. Latency on 3 is going to be good because it's almost like it was on its own. Okay? So we're going to get more messages through. Why? Because there's overhead for sending something over the network. When we batch things together, we send it over all together as 1. We're going to save time doing that. Okay? as opposed to sending them individually, 1, 1, 1, 1. We have to pay the network latency on each one of those, okay? So that's why we do batch things up instead of just sending them individually. I said I wouldn't explain anything, but I'm going to explain this one a little bit just so that we can start on a good footing, okay? So here we're talking about batch management. We've got a producer sending messages to a broker. They do that by partition. There's a batch per partition, and a topic is shared across multiple partitions, okay? On the other side, we're going to unwrap that by partitions will have multiple segments, one of them which will be active, which we'll actually be writing to, okay? So I've given you some vernacular so that we can start having a conversation. So now we can talk about batch size. How many messages make up, or sorry, how many megabytes actually make up the size of the message that the size of the batch that we want to send? Not the size of the message, the size of the batch we want to send, okay? And linger MS. Linger is saying, how long do I want to wait before I send a batch? So I'm not going to wait necessarily for all of the data to be full. Maybe that'll never happen, okay? I can set a cap on time. So I can set a cap on data, size, and time. These are the two ways that you generally control your batch size. There are some other ways that also do it, and if, again, for completeness, you can actually have a piggyback, or you can have a flush or close. So you call flush, it's going to get sent. You call close, it's going to get sent. And then you've got this odd one called piggyback, which is hidden for most people, but I'll go into it because you guys are getting your cameras up. A piggyback is when you are sending data already to a broker, and the producer is smart enough to say, okay, well, I've got something from topic A and then from topic B, and they're going to the same broker, I can send it. Or it could even be, I know that there's 2 partitions on that broker, so I'll send it. So you're not waiting for the linger MS to fulfill the time contract, or the batch size to fulfill the data size contract. You're just like piggybacking it on like a hitchhiker, like, why not? I'll send you. I'm sending stuff anyways, why don't I send you too? Okay. So we have this relationship that the buffer memory must be smaller, or must be larger than the message size, so much the batch size, okay? If you think about this, this makes sense. We won't actually send a batch we won't actually send any messages unless they're smaller than the batch. They must be. And the same thing would go with the buffer. If the message is completely bigger than the buffer, you also won't send it. Because by virtue of that, it would also be bigger than the batch size, and then it wouldn't fit into memory. Okay? So this makes sense from a perspective, but if we bring in linger MS, it starts changing the equations around. Well, it doesn't change the equation, but it has an effect. Whereas these are all set by megabytes right now, theoretically. We start messing with linger MS, then it changes things. Here, the batch is full because the data is completed because linger MS is long enough so that I can complete my contract on filling up the data, okay? There was enough data that entered into the batch that it triggered the full, and it sent it, okay? If linger MS is small, then I don't have as much opportunity to fill these things in, and I can start playing with things. So the batch size will not be the batch size, in fact. And the message size could actually increase because we don't have to worry about the batch as much anymore. What does that mean? Here's a picture to help illustrate. Linger is triggering it before the batch is full. I can now put bigger messages theoretically in because I know linger MS is going to send it faster. So I might want to have more smaller messages so that I fill the batch size up. And what are we trying to do here? You're trying to optimize both of these so that if you push it a little bit one way on one or a little bit on the other way on the other, they're both triggering, right? You don't want one of these to be significantly larger than the other. So if you were doing testing, you want to find the point where these two kind of cross over in performance, and that's the good place to have it. And it doesn't matter if you're a little bit on one side or a little bit on the other. You want linger, MS, and batch size to be triggering almost simultaneously, and you've got the best throughput contract for you. You're not using any extra resources. You have to tune your batch size, and let's go back. Sometimes I lose my words. You have to tune your buffer size according to the batch size that you want. And so when we're doing that, it's a lot easier if we're using Linger MS to bring everything down. Here's a slide that helps to wrap that up. If we increase the batch size and increase Linger MS, what should happen? We should get more throughput. We're going to get more messages into that batch. However, we're going to do that at the cost of latency. The latency will increase, which is going to be bad. Your messages, sure, you'll get them done efficiently and efficiently across the network, but you're actually going to increase the individual timing of these messages. If you decrease the batch size and you decrease Linger MS, then it holds true that both the latency will go down, but also will throughput. So each individual message will get across faster. And you could even think of the use case that, OK, well, I'll just make the batch size the same size as the message size, and then I'm just sending one all the time. Aha, I figured it out. That's not going to do you any good. Your latency will be great on the per message basis, but their throughput will go down. You won't be able to get enough messages over because you'll be constantly paying overhead. And to be honest with you, that's not completely true. That might be completely acceptable. It might actually be intended. Okay? Maybe you need to have these messages going through at that latency rate. Okay? If we popped over to streaming, streaming understands both of these concepts. Okay? That we can have a high latency thing and do mini batches. There you go, micro batch, done. That's exactly what we're talking about. Or getting through on an individual basis. Maybe it's a fraud transaction or a fraudulent transaction, and you want to have individual latency. You need to understand on a per message basis of what's happening. And then just don't forget to tune your buffer afterwards. Okay. Compression I'll go into a little bit more. I've got a great live demo that we can go into to talk more about it. But basically, the gist of it is, look, if we can decrease the amount that we're actually shipping across, well, then it should go faster. If it's a smaller message, it will get over the network faster. Okay? And of course, this is one of those things that has a nice curve like this. So as the message size goes up, okay, you get an increase in performance, and then eventually you'll start getting a decrease in performance because you'll make the message size too large, and the computation of the zipping or the snapping won't work out for you. There's also ways that you can tune this in compression. You can actually turn up the user threads on your producers to help handle the compression. The trick there is, though, that you also might run into contention eventually as the threads kind of start tripping over each other. So to a certain point, you'll get a bonus, and then after that, again, you'll see that decline in your curve. Okay. So when we're other areas that you can actually get some more performance, just out of the box, going away from the out-of-the-box defaults, is your serializer and your partitioner. They both are pluggable in Kafka, and if you find a particular serializer that's better for your data set, you might actually get some extra performance out of it. Same goes with partitioner. Okay. So partitioner is really good to talk about because this is like a merge sort. It's a freebie, or I like to think about it as a freebie. Okay. And we all remember back to merge sort, of course, where it does some sorting on the way down in the algorithm that naturally works out on the way back up. Okay. If you don't remember, I'll give you the money. What we can do with that is we can actually use that as something we know for later on. So if we can partition according to a particular piece of data that might be valuable downstream. I'll give you an example. It's kind of contrived, but it works. So auctions. Okay? If you want to know who the winner of an auction is, you have to know in what time and what order that they bid. Well, a partitioner will help you with that because why? If you put all of the events for one auction to the same partition, all you have to do is see the last person in that partition and you know who the winner is, right? If you set it up so that every single partition was a different auction and they're all unique there. So that could save you a lot of calculation time down the road because, of course, we all remember that partitions have an absolute ordering to them. which is convenient for a situation like auctions. There's other areas where this can also be valuable. Okay? The other reason I mentioned partitioners, if someone got their kid brother to write a partitioner for them and it's performing very badly, well, then you might want to go back to using some of the stock seatbelt one, okay? Which actually is just a hash, and it works quite well, okay? The other thing that might be beneficial to you is you might be seeing skew. And skew you also see in your partitions. So if you don't know what skew means, if it's the first time you're encountering it, you think of a hockey stick, okay? One of the graphs with a hockey stick, there's not an even distribution here because it's going severely up on the wrong side that you don't want it. So how do you redistribute that data across your partitions so that it's in order that's well balanced, so that the workload is being shared across multiple things? You could write a partitioner with a salt to help you out with that situation, okay? And that's actually, I think it's pretty well documented online, but look up salt partitioning and you should be able to find that in terms of how to bring that back. We talked about serializers. If someone went off and wrote your own serializer 20 years ago, maybe try it out against one of the ones that we have today. I don't think actually Kafka was around 20 years ago, but anyways. And the interceptors. Interceptors are part of Kafka, and they're getting a lot more into it, or sorry, they're breaking away from what were interceptors. So if you still do have some in Kafka, you might want to consider moving them out into some other streaming library. Maybe it makes sense. Maybe they're more performant if you do that. Maybe it's just fine because really it's not doing that much. In any case, if we're talking about performance, here's somewhere we want to make sure that the interceptors that you are using are written in a solid way and weren't just written on a Friday night because they had to have it done, okay? Maybe it was like 6 o'clock just before they got a chance to go for cocktails when, I've already touched on this. You do need to actually do real-world testing, okay? I'm going to go into it with a toy tool that's included with Kafka, which will help you to understand the type of testing that we need to do. And there is no one-size-fits-all. You should do testing with it. Here's the class that's included inside the distribution, okay? Go figure, it's kafka.run is what actually does the work, but there's a nice script that kind of helps you out with that and actually does the work for you, okay? There's a producer and a consumer. This is critical. You've got to have them both if you want to see it. To be honest with you, the consumer is probably not your problem because most people provision enough so that that's not actually the problem, right? Those guys are working hard to try and keep up, but the one that's usually putting all the data in, which causes all the problems, is actually on the producer side, right? Okay. And a quick walkthrough. So here I've got my Zeppelin. Can you guys read that okay? I think that's better. Okay. So here you see me create the topic and then run a simple test on it. There's no magic here. This is one of my favorite parts about Zeppelin is that you can actually run everything in advance and it saves the output. So I'm doing a live demo, but I've already done it and I know it works. Okay. You can see here that I'm running a simple performance test. What's critical to see is that we're running the script, running it against our topic with a batch size. Okay. The broker list, that's simple. That's just the address of where my zookeeper is. The message size I can define, and the number of messages that I want to send. Okay. You should play with these numbers. Just running one simple test is not enough, okay? The other thing that I would suggest doing is make sure that if you're not going to test real data, that you at least let this run for a solid minute so that it has enough time to get through any variance that might throw off your test. Don't run a 30-second one and go, aha, I found the answer, okay? See, now this looks better, okay. So now we're varying the quantity of messages. We're doing it in a loop. You see that header dash hide down at the bottom, Okay, that's just so that my chart looks nice because I'm actually running this 3 times. Okay, it would have been actually a lot nicer if they put this in so that you didn't have to script it and be a little bit of a shell hacker. Okay, that's better. We're testing things. We're seeing how things perform. Oh, wait, we can do better. Now we've got the compression type in there as well. We also have the quantity. Okay, but let's throw in the size of the messages as well. I mean, this is quite readable to me, but maybe we could put it into a chart. So I do some magic in the background, a little bit of Scala scripting. And then I produce this nice chart. And here's the whole reason why we use Zeppelin, so that we can have pretty charts and see them. So you can see that the no compression is actually working really well on the 100. And the zip, it doesn't do it. Compressing it doesn't actually help out to start with. We're still getting more messages through just with no compression. Okay. Let's look at 500. And you might want to notice that the scale that I have here is logarithmic. So it says 1, 2, 3, 4. That's actually 10, 100, 1,000, and then 10,000. And if the chart would update, okay, live demo, gotta like it. Let's try it again. Oh, wait, that's why. All right, we're connected, we're back. And we'll try my charts one more time. Beautiful. Okay, so now compression is not winning. Okay. What is winning is LZ4. Okay. And you can see compression actually is really not winning. Okay. And then do we have a winner? No. At this point, there was an issue with the script. The only reason I've kept this here, though, is to show you that gzip actually started to lose to uncompressed. Okay? And why? That's because the messages actually finally got up big enough so that it no longer made sense. They were spending so much time with the compression and decompression that it didn't work out. Okay? So I apologize that there's not a lot of data points there, but it's important. The important part was to see was that the performance went back down on the curve. Okay? In fact, whenever you're doing performance testing, this is what you want to see. You want to see it get better, get better, get better, and get worse. Why? I found the peak, okay? I found the optimal line. If I haven't hit the optimal line yet, keep going. You're not far enough yet. Once you start to see the fall off in the curve, then you know that you've gone past and you know where it should be. Okay. Great. Oh, good, guys. We might actually get some time for questions at the end of this. I'm on my 40th slide, and we're not at 40 minutes. That's good. Okay. So you may say to yourself, but Matt, there must be a better way. Surely I don't have to do this work myself. Yes, absolutely, there's a better way. Okay? There are monitoring tools that you can use. Okay? These make my life a lot easier. If I'm going to come help you guys, or if you're going to have someone else come in and help, if you have a monitoring tool, it makes life a lot easier. Generally speaking, Ops Clarity just got bought out by Lightbend. They're kind of the Cadillac of monitoring. I think they've got everything that you need. I find them a little bit better than Burrow. Burrow is a little bit more resource hungry, and it's not as good at finding consumer lag. It gives some false positives. Preparing for this lecture, found a couple more, so I threw them on the slides just so you can be aware of them. Yahoo's come out with a Kafka manager as well. Confluent Control Center also does that. You know that Confluent is the people that are the main supporters of Kafka. So this should be a very good engine, in fact. You do need to be using their distro, though, which is acceptable, but maybe it throws it off for a couple people. Of course, if you want to get hardcore, you can just go out and use JMX, and there are MBeans that are actually used for all of this monitoring. Okay? So underneath, really, that's all you need to do is use JConsole. It's on your computer already. You had installed Java. You can read these. Okay, a quick aside. This is we're right before the end of the day, so I thought I'd throw this in. So this is my guess about why this is called it. I watched this Kafka video, And then I was like, okay, I've got it. I know why he calls it Kafka, okay? So he puts up this like horrible, horrible drawing and says, if there's only a better way, I can dream of a better way. And then he goes, this would be amazing. And then I find this inspirational quote from Franz Kafka. And I'm like, okay, this is it. This is why he said it. He was inspired, okay? This is exactly what it was. And then I searched it on the internet. And of course, I found him reply to an actual post about why it's called Kafka, which is great. Jay Krebs used to work at LinkedIn and was one of the founders of this. And he says, I thought it was cool. It's a system that does writing, so it should be a writer. And I really liked his work at the time, okay? But the really important part that we see here is that he says, it's a system optimized for writing, okay? So that's the part I want you to take away from his thing. So let's optimize the writing. And before we even do that, let's think about how much writing we're going to do, okay? So when you're going to set up your cluster, you need to think about the number of partitions that you're going to need for the lifetime of the cluster. Or let's face it, 2 years, because by then you'll upgrade or do something else. Okay. You always need to pick more than you need in terms of doing that, okay? You can decrease the amount of space that you need. Watch out for the unlimited retention of log files. If your machine gets turned up because you go through a fantastic boost in business, you're going to run through your log space way too quickly, so be aware of it. You should be tuning the number of I/O threads to match up with the number of physical drives that you have. By default, it's 8. That's pretty safe. If you put more than 8 drives in, you can actually up the number and then have 1 thread per drive writing, which is the goal, okay? So let's talk about how you should tune, okay? So your tuning should come from the throughput that you need, okay? It's going to come from one of these two sides. It's either going to be from the producer or from the consumer, okay? One of those two is going to be your limiting threshold. Normally, it's the producer, okay? If it's the consumer, you're in trouble. Why? Because the whole point is this should save the logs long enough for you to be able to read them. If you're suffering what's called consumer lag, your consumer is not able to keep up to Kafka. Okay, the amount of the producing that you have is a problem. So what can you do? Oh, I'm going really quick now. Oh yeah, you should also tune your watermark, but this is off topic. I'll come back to it. You can increase in your consumer group the number of threads that's used to pull the messages off. Okay, this is important. Why? Because it links back to the number of partitions that we were talking about earlier. Okay? Each partition is read by exactly 1 consumer. Okay? There's a one-to-many relationship there, but yes, generally speaking, we can increase the number of threads. And you can get more things off of the server faster. Still ingesting it from that point into whatever source system you're in, that's another problem you have to solve. So increasing the number of partitions increases the level of parallelism, also the number of open files. It increases the amount of memory usage because why? You need something to manage the writing of this. And it's something that you should keep an eye on is the leader failure over time. Okay? As you increase the number of brokers, this actually helps to mitigate this issue. Oh, guys, we're going over, so I'm going to go really, really quick just to make sure I said it, but we can stay afterwards and talk about it. Okay? How do you calculate the number of partitions per broker? Okay? The number of partitions per broker should be the number of brokers multiplied by the replication factor, multiplied by some number C, which is your appetite for risk, your machine's awesome prowess. Also, 100 is a good starting point. Okay? And then test it, test it, test it. Okay? This is generally a good place to start. You shouldn't be afraid of it, but you can definitely do more by testing. Okay? If you are testing to try the true performance, what I do suggest is you start with actually 1 partition. Okay? And you get a producer and you produce as many realistic messages as you can, and you see what the throughput is that you get, and then you use that as a multiplier to figure out how many actual partitions you're going to need. Okay? So instead of just using what the machine can handle. This is a freebie. When you are using a Kafka cluster, one of the first things that I check out to make my life better is whether the partitions are evenly distributed and the leadership of those partitions is evenly distributed across the brokers. There's a fantastic tool that's already built in that will do the rebalancing for you, okay? Amazingly, it's not built in somehow because I think they don't know when your maintenance slot is, but they really should just have a button that you press and it just rebalances everything for you. Or it says, hey, it's time to rebalance. Okay. And I think we got to the end of it. There's so much more on the topic to tell, but we don't have the time to do it today. I'm going to be in the next room where I'll answer even more questions, but right now I think we've got time for a couple. Okay? So I'm Matt Andriff. I'm not an expert, I just sound like one. Any questions? Yeah. Oh, we'll go here and then there, because he's right here and you're there.
So I guess, can you hear me? Okay.
Yeah, sure.
So one of the biggest problem we have within the brokers is the time it takes for fetch.
Time it takes to, sorry,
yeah,
one of the biggest problems you have with your brokers is that you have?
Fetch, right? How can I tune my fetches from one broker to another?
How can you switch from one broker to another?
No, tuning the fetch between the brokers, like the replicas fetching from the leaders.
Oh, the replicas. Thank you for bringing that up. There's a thread count that you can put up. So A, increase the number of your brokers. B, you can actually increase the time that it takes to write to replicas is actually the number is by the number of brokers. There's one thread per broker to write to another replica. The fastest way to fix your life is to buy another broker. So go out, buy another machine, make more brokers, and you're going to get better performance for that. Because there's only one thread that writes to the other replicas per broker.
Right. But if your cluster size is already so big, if you have a big cluster, like let's say 100 nodes.
If you have a big cluster, then let's talk about what you're doing with that. There's probably more underlying factors than I can answer right now.
Okay.
There's a question over there.
So we're using JPod, and the production cluster is about 16 disks per broker. Now the issue that we're seeing on this that some of the disks are highly utilized and some of the disks are not doing anything. So to go around that, I was trying to see if there was any best practice. So what I was kind of thinking is that if in order to rebalance is either the disk that is highly utilized, that's the one that's that topic is putting a lot of data onto that partition and on that disk. So is that okay to add another disk to that volume and increase the size of that, or just rearrange the entire disk layout for Kafka? What's the best way to get around the situation?
You're most likely suffering from what's called skew, because you have one partition that's actually way more active than the other ones.
That is correct.
Right. So you might want to consider writing a custom a custom partitioner, like I was saying, to actually do a better distribution of your data across that. And to figure out what that is going to be difficult, because you'll have to look at what the keys are for the clusters and figuring out why it's chunking all that data together. It may be quite simple if you look at it, but I suggest writing a custom partitioner for that so that you distribute the load better.
Okay, thank you.
There is a producer performance metric, consumer performance metric, and broker performance metric. So in our case, let's say our consumer is a Flume agent. When we have a problem in a consumer performance, should we change our Flume agent, or let's say a custom Java code, which is our consumer, or a Kafka?
Specifically, if you're using Flume, you can actually have more Flume agents writing to the channel, which would probably relieve you some of your stress. So you could add additional Flume agents.
Okay. Yeah.
Thanks, Matt. Sorry, but we have to wrap it up.
Okay. I'm going to slowly walk that way. If anyone wants to ask me a question, please do.
Thank you. Sorry about that, gentlemen. We need to clear the room.
It's all my fault.
Not at all.